Hi everyone, welcome to Android Lab. In this video, we're going to learn how to load data from a JSON file inside the Assets folder and sync it into a Room database. First, create an Assets folder under src main, and then add the data.json file to that folder. Now let's create a data class called SoundAssetTripper. This will represent the structure of our data.json file. It has 5 properties: version, featured playlist DD, and 3 lists: groups, playlists, and sounds. We're using @serializedName to map each JSON field to the corresponding property in our Kotlin class. Version. This is used to track the version of the data. Later in the code, we'll compare this version with the one in shared preferences. If the versions don't match, we'll update the database with new data. Featured playlist ID. This holds the ID of the playlist we want to feature, meaning show it first or highlight it in the UI. Groups. This is a list of group objects. Each group represents a category, and inside each group we have multiple playlists linked by their ID. Next, let's set up Hilt in our Android project. Hilt is a dependency injection library built on top of Dagger. It helps you manage dependencies like view models, repositories, and other objects without having to create or pass them manually everywhere in your app. Think of it like a smart delivery system. Instead of you creating objects yourself, Hilt gives them to you when you need them. Here, we're opening the data.json file from the Assets folder, reading its content as a string, and then using Guillen to parse it into a SoundAssetTrapper object. We use type token here because SoundAssetTrapper contains nested lists, and Guillen needs to know the exact type. Here, I'm creating a class called SharedPref, which is a wrap around Android's shared preferences. We use shared preferences to store small pieces of data locally on the device, things like user settings, flags, or app version numbers. In this case, I'm using it to store the version of the sound data we've already inserted into the database. That way, we can check later whether we need to sync new data or not. It's a lightweight and persistent storage, perfect for things that don't change too often but need to be remembered between app launches. Originally, I had an interface called SharedPref, along with its implementation SharedPref Pimple. This is a common pattern when you're using dependency injection. You define an interface for flexibility and testability. But in this case, I realized that we only have one implementation of it, and it's not likely to change. So I decided to simplify the code by removing the interface and using the implementation class directly. This helps reduce boilerplate and makes the code easier to read, especially for small utility classes like this. Here, I'm creating a class called Playlist Mapper. This class is responsible for converting data from one type to another. Specifically, it takes a playlist set, which is the format we get from the JSON file, and maps it into a playlist entity, which is the format we store in the database. We use @inject constructors so that this mapper can be injected using Hilt wherever it's needed. For the sake of time, I've already prepared some of the classes we'll need, like the models, entities, and mappers, so I'll just paste them in as we go. Now let's add Room to our project. Room is the official persistence library from Google that makes working with SQLite databases much easier and safer. At entity table name equals playlist. This tells Room that this class represents a table in the database, and the table name will be playlist. At primary key autogenerate equals false, marks this field as the primary key. Autogenerate equals false means we will manually assign the ID, not let Room generate it. At column info name equals ID, maps this property to a column named ID in the database. In the mapping function, we just copy over the properties like ID, name, description, and thumbnail. From user is set to false because this playlist comes from the assets, not created by the user. This is the playlist DAO interface, which defines how we interact with the playlist table in our Room database. We're using the @insert annotation here to insert a list of playlist entity objects into the database. The onConflict equals onConflict strategy replace part means if a playlist with the same ID already exists, it will be replaced with the new one, which helps prevent duplicate entries. This class sound playlist crossref represents a many-to-many relationship between sound entity and playlist entity. @entity defines a join table named sound playlist crossref. We set a composite primary key using both sound ID and playlist ID, meaning each sound can only appear once in each playlist. Here we define foreign key constraints linking to both sound entity and playlist entity. If a sound or a playlist is deleted, any related rows in this join table will also be deleted, thanks to &delete equals cascade. We add indexes on both columns to make database lookups faster, especially when querying playlists by sound or vice versa. This function deletes all the records in the sound playlist crossref table where is user created is false, or, in other words, where the link between sound and playlist was not created by the user. We usually call this when we want to clear all auto-generated data before syncing a fresh set from assets, without touching user-created playlists. This is the main room database class, sound database. It defines a list of all entities or tables in our database and gives access to all DAOs we'll use to interact with those tables. This is a blocked sound entity, which represents a list of sounds that the user has blocked. Each record contains a sound ID, which links to a sound in the sound entity table, and a block that timestamped to record when it was blocked. We use that foreign key to make sure the sound ID is valid. It must match an existing sound. And with delete equals cascade, if the sound is deleted from the main table, it's also removed here. This is useful if we want to hide or filter out sounds the user doesn't want to see or hear. This is similar to the blocked sounds table. It's used to store the sounds that the user has marked as favorite. This one is also similar. It's used to store recently opened playlists, along with the timestamp of when they were accessed. This one is just like the recent playlist table, but for sounds. It stores the last time a sound was played or opened by the user. Now I'm creating a database module. This is a Hilt module that provides the room database and its DAOs to the rest of the app. By putting this in a module, we can inject the database and all related DAOs anywhere using Hilt, without having to manually create them every time. At first I made a small mistake here, but I've fixed it now. It should look like this. Alright, that's it for this video. We've successfully loaded data from the Assets folder into our Room database. In the next video, we'll build the UI to display that data on screen, so stay tuned. If you found this helpful, feel free to like, share, and subscribe for more Android content.